Oh, hello. Hi, everybody. Hello, hello. My name is Kim Ryder, and I'm the Director of Operations here at the Wayne. I want to say hello and thank you for being here and welcome. On behalf of our Board of Directors and staff and amazing ambassadors, we appreciate you being here tonight. So before we get started with this amazing program this evening, I wanted to tell you just a couple things that are coming up at the Wayne Theater. Soon we are going to have Jim Messina in the house. How about that? Loggins and Messina fame. Oh, lights, thank you. And also, let's see, upstairs in our Custon Cabaret, starting on the 20th, we are going to have Dial M for Murder in a lovely, small, intimate space. It seats only 50. It's a really wonderful venue for this incredible little theater thriller. So join us for that. And later on in November as well, we have Nonsense coming up for 2 weekends. We have Emmett Cahill and Pam Tillis, a couple of dates in December. Gaelic Storm in November. So we've got a lot going on. We really appreciate that you're here tonight, but I know you're in for a big treat. And I want to do an introduction of Miss Jenna Konizer, and she will introduce the speaker.
Good evening. Can you hear me? Nope. Okay, now hear me. So first I'd like to thank all of you in the audience here for coming tonight and those that will be watching online, and say that we are very grateful for the sponsors of the Science Talks, and that is including the Wayne Theater, of course, the Virginia Museum of Natural History, the Center for Cold Waters Restoration here in our area, and the South River Watershed Coalition, which used to be called the South River Science Team. We invite you to join us next month on the 15th for a science talk on investigating landslides in Virginia. That's pretty relevant, isn't it? It's presented by Ann Carter-Witt, who is a geohazards geologist with the Virginia Department of Energy. If you have suggestions for future science talks, we would love to hear from you, and if you would like to be notified about the science talks, I have a blue clipboard in the lobby that you could put your contact information on. Joe Kuiper, the executive director of the Virginia Museum of Natural History, couldn't be here tonight, but asked me to give you a short update on what's going on with the Waynesboro Branch Museum. So Glave and Holmes Architecture has been hired to create the detailed designs of the Waynesboro Branch Museum. We will be able to see the updated building drawings later this fall. Something to look forward to. The final project and cost figures will be presented to the General Assembly for approval during this winter session. And we have our fingers crossed that the groundbreaking for our Waynesboro Museum will happen sometime in the year 2024. More information about this is available at our local Waynesboro Public Library, as well as 2 now life-size dinosaur skeletons for you to see. I hope you'll check them out if you haven't been there yet. So, tonight's speaker is Rick Reynolds, a wildlife biologist with the Virginia Department of Wildlife Resources. He is an expert on bats in Virginia and has authored the department's guidance document on best management practices for the conservation of little brown bats and tricolored bats. Bats are the top predators of the night-flying insects, so they are an essential part of our ecosystem, and some species are currently endangered. So we are very glad that you're here tonight, or viewing tonight, to learn more about to help them survive. Please welcome Rick Reynolds.
All right, can you all hear me? Does that work well? We're good? All right, thank you. And again, a welcome for coming this evening, and I think it's kind of appropriate that getting close to Halloween here that we're going to talk about bats. And if you didn't see it or didn't get it, I brought copies of the Guide to the Bats of Virginia, and they're out front. So if you didn't get one when you came in, please pick one up on your way out. So tonight, I'm going to kind of do an overview of bats and kind of bat biology, and then focus on a couple of issues that are affecting or impacting bats today. So let's go ahead and get started. So I think before you really talk about any species or taxa group, it's good to have a little bit of understanding about kind of the biology of the critter that you're going to talk about, mainly because there are probably traits and life history characteristics that eventually kind of explain the situations that they're in and why they're in the condition that they're in. So we're going to start off with just kind of a quick Bat Bio 101. And so bats, as you know, are mammals just like you and I. And they're mammals for three main reasons. And that's one, they bear their young live. Two, they feed their young milk. Not like us, not cow's milk. And third, they have hair or fur. And so that's kind of where they have those common characteristics with mammals. But obviously, from the fact that bats can fly, that makes them a special group of mammals. And they are the only ones that can sustain flight. So we've got other mammals out there, with the misnomer of flying squirrel, and they're sugar gliders. Basically, they kind of have a controlled glide, if you will. They don't actually sustain flight, like bats do. And bats fly pretty much as well as birds do and can do a lot of the maneuvers that birds do as well. So because they're unique like that, they're put in their own order called Chiroptera, which means hand wing. And it's pretty obvious when you look at this outline of a bat why it's called that. So its head and body and legs are kind of proportional, but let's see if I can get this light to work here. But when you look at them, mostly that wing is a hand. So here you see a thumb and 1, 2, 3, the 4 fingers with it. It's got kind of a short upper arm, the forearm, and then all that is sandwiched with a couple layers of skin. And then, of course, the tail membrane as well. So if we look at bats from a world perspective, there are over 14,000 species of bats. And of course, being humans, we always like to categorize things. So we basically can categorize our bats into two major categories. And basically, it is kind of size that does it. So you're either a big bat, so we call you a Megachiroptera, or you're a small bat, you're a micro. And of the 1,400 species, over 1,200 are the Megachiropterans. So they're the flying foxes, the fruit-eating bats. They're the bats that you find down in the tropics. And then what we have here, pretty much in the United States, and certainly back here in the East, are the Microchiropterans, basically your insect-eating bats. And a couple of those, the bat here in the middle is a hoary bat. That is the biggest bat that we have here in Virginia. So in Virginia, over 1,400 bats, and we really only have about 17 species that we've recorded here in Virginia. So we're not a real hot spot for species diversity for bats. But much like we categorize the other bats, we can do the same here with the bats that we have in Virginia. And it pretty much depends on where you spend the winter or where you hibernate. So if you hibernate in a cave, we pigeonhole you as a cave bat. If you're out on the landscape hibernating in a tree or you're under a log, then we call you a tree bat. So there are only 3 species of tree bats here in Virginia: the red, the hoary, and the silver-haired. And you see the silver-haired bat here in the lower right-hand corner. And those are Virginia big-eared bats that are up in the left-hand corner. One of the differences between those, and you can sort of kind of see it here with the silver-haired bat, but its tail membrane is furred. So with our tree bats that are kind of like out more on the landscape than the cave bats, they have this extra protection with fur on their tail membrane, whereas the cave bats have a naked tail to them. So some of the life history traits that are different than other mammals. When you look at our bats, they really are small. They are mouse size, but they really differ from mouse, in the way that they perpetuate their species. So when you think about mice and voles and shrews, their whole approach to keeping their species going really is one of that they have multiple litters and they have big litters, but their life expectancy is very short, 1 or 2 years typically. And bats have taken a different approach to it. They're long-lived, 12 plus years in the wild's not unheard of, and in captivity 30 years or so. But their productivity is different, and this is important with some of the things I'm going to be showing you a little bit later. So for the most part, it's 1 to 2 young per year. Now, the tree bats, typically they have twins, and the red bat can have 3 or 4 pups. But for the most part, all of our bats have 1 or 2 pups. Most of the cave bats, just 1 pup per year. Yeah, so only 1 litter per year, regardless of whether you're a cave or a tree bat. Also, all the bats that we have here in Virginia and basically here in the East are insect-eating bats. So when you think about that, you really only have a couple approaches to what you're going to do when winter rolls around and your food source is no longer there. So you can either pack your bags, head south, get to some warmer climates where there's a little bit more insect activity, or in the case of our bats, they go into hibernation. So fall rolls around like we have right now, and they go into this period that we refer to as fall swarm. Whereas for the cave bats, they hang around cave entrances and swarm around cave entrances this time of year, waiting for it to really cool down. And what they do is they build up their fat reserves, they go into hibernation, and they have enough fat reserves basically to get them through the winter time. And, no one could really go and hang out on the side of a wall or a ceiling for 5 or 6 months waiting for spring to roll around. So the bats do get up, stretch their wings, go get a drink. When we've got warm weather, say in January and February, and we get 60 to 70 degree days, there is insect activity out there, and they will go out and they'll fly around and they will get a bite to eat while they're stretching their wings. So oftentimes I'm asked, well, why should we care about bats? I've lived my whole life basically without them, and I don't know what they've really done for me. So I just want to show you a few areas in which we really do gain a lot from bats and the study of bats. And the first one is just looking at the ecological importance. So you always hear about things are intertwined together out there in nature, and one species is dependent upon another, or a habitat's dependent upon ones. And the same thing happens here with bats. So we're looking at this more we're backing out, looking at this from a world perspective. And here you're looking at the fruit-eating bats and the pollinators out there. And the slide in the middle, all of those products have benefited from bats, whether it's seed dispersal or pollination of the plants that they come from. There's an economic importance to bats as well. And again, we're going to look at it more from this world perspective and bring it down more to Virginia and the eastern United States. But there's this fruit called a durian fruit that's in Southeast Asia. From what I've read about it, it's an acquired taste, I guess. But yet it's quite a product out there when it brings in $100 million a year. And basically it relies on bats, to pollinate the flowers. And in Malaysia, kind of a different way of, utilizing bats is with the use of their guano, and that being the fertilizer that they use for their pepper crops. And lastly, this bottom bullet shows you what a colony of little brown bats can do as far as keeping agricultural pests in check. So you can see how many, different, beetles and June bugs and stuff that they can eat in one season. They took that information and they extrapolated that across the range of the big brown bat and where the big brown bat overlaps with agribusiness out there. And what they came up with is that, just in the reduction or the reduced use of pesticides out there, they save agriculture between $4 and $50 billion a year. And so that's not really chump change, even if you go to the lower end there of $4 billion. And that's just, and that doesn't have anything to do with, when you apply a pesticide, it doesn't really stay on the 1 acre that you apply it on. There's always runoff and issues that go along with that as well. And lastly, there's a scientific importance with bats as well. Just because of the life history traits of longevity, they really are disease resistant, other than one of the topics I'm going to talk about. Their echolocation calls, they can survive extreme temperatures. Little brown bats can survive down around freezing. They have delayed fertilization. So when I was talking about the fall swarm period, not only are they out there feeding up and getting their fat reserves in place, that's also the reproductive period as well. But the females will not fertilize the egg until the spring. And so they have basically the choice there. As long as they've got the good body condition, they can have a pup or two. And so with all of that, they've all helped in the study of aging and contraception and artificial insemination and such. All right, so let's get into talking about the issues that are really impacting bats today. And I have this as like 2 newer issues. Well, they're really not new issues anymore. So white nose syndrome, which a lot of you are probably familiar with, has been around for over a decade, and wind energy has probably been around for a few decades now. So we're going to go ahead and we'll cover the topic of white nose syndrome. So if you're not familiar, this is a cold-loving fungus that was brought over from Eurasia. Exactly where it came, whether it's Europe or Asia, I don't think they've really pinpointed that. But it being a cold-loving fungus, basically it exists until you get up to about 70 degrees, and then it no longer flourishes, at least the fungus does. The name of it, or the scientific name, is Pseudogymnoascus destructans, and it is what's caused quite a bit of mortality in certain species of bats here in the United States. So it kind of got coined, this name of white nose fungus, because when you went into a cave, so this is a winter situation, our bats go into caves to hibernate. And when they go into hibernate, they have fidelity not only to the cave that they go to, but typically to passages in the cave. And those passages are usually in the low to mid 40-degree range. There are bats that can tolerate colder and warmer temperatures than that, but most of them are in that 40 to upper 40 temperature range. That is also the prime growing temperature for the white nose syndrome. So it's really not a good scenario when you're in a situation with this fungus, and it's the best growing conditions for them as well. So when we would first go into these caves, and when white nose was first around, you'd look up on the ceilings or on the walls where the bats were hanging out, and what really jumped out at you was this fungus on their nose. So it grows on any of the exposed skin that they have, and basically what you see first is this white fungus around their muzzle. but it does grow. When you look closer at them, you'll see it on the ears, you'll see it on the wings and on the tail membranes. And so we talked about, the bats building up fat reserves. This fungus grows into the dermis of the bats, and you can imagine what an irritant that is. So basically, they end up waking up probably twice as much as they normally would. And so when you do that, you've gone into hibernation, you lowered your body temperature to the ambient temperature of the cave, say mid-40s or so. Anytime you get disturbed, you've got to raise that body temperature. You end up using up those fat reserves. And basically, come the middle of winter, if you've been woken up too much, then all of a sudden you're going to be hungry. You don't have the fat reserves there. You fly out in the middle of January or middle of February, and you're not going to find much of a food source out there. The other thing the fungus does is it really disrupts the water balance just because it is penetrating the skin there. So you just think of everything that's associated with water balance and hydration and such, and it's basically a death of 1,000 stab wounds. So I'm going to go through this kind of quickly, but it first showed up in, I think it was about 4 or 5 caves just outside of Albany, New York, back in 2006. We jump a year, it moves further into New York and the adjoining states. Another year, it's running down the Appalachians. It's in Pennsylvania, West Virginia, Jump a couple more years, now it's running north, south, and west. And then in 2016, it was kind of odd to all of a sudden, if you look out at Washington, there are a couple spots out there where it showed up outside of Seattle. And I don't have a real good explanation as to how it showed up there. Possibly it could have been, brought over to the port, around Seattle. And there might be an outside chance that you had bats moving that far from east to west. And then we keep moving through the years and it keeps spreading. And this is what the most current map looks like. So the status has been confirmed in 38 states and 8 Canadian provinces. There are 20 species of bats that are affected or exposed. So you're affected if you get the spores and the spores develop in the fungus and you end up with the disease. You're exposed if you're basically a carrier. So you've got the spores on you, but they're not necessarily developing into the white nose fungus. And so you can kind of see here there are 12 species that are affected and 8 more that have been exposed. And so I realize that those 4-letter acronyms don't mean anything to you, but they are the first 2 letters of the genus, and the last 2 letters are the first letters of the species. And so when I had mentioned that this is a cave bat issue, there are 2 of these species that are exposed. These 2 here, the LABO and the LANO, are actually tree bats. So LABO is the red bat and the other one is the silver-haired bat. So they've been found to have the spores on them, but the spores don't develop into the fungus. So impacts to date, and this is old. This is back from 2015 when basically they asked the states to kind of come up with some figures as to how many bats they felt were impacted by white nose syndrome, impacted being that they're dead. But so back then it was 5 to 6 million bats. But interesting is that not all species are affected the same. So little browns, tricolored, northern long-eared bats, they got hit pretty hard by this. Certainly in Virginia and back here in the east and now into the Midwest, probably greater than 90% declines for those 3 species. But there are other bats. Big brown bats don't seem to be as heavily impacted by it, and a couple other species, gray bats. I showed you that Virginia big-eared bat earlier. They've been swabbed and they've picked up the spores on them, but the spores are not turning into the fungus and impacting the species. So what I thought I would show you here is kind of how we came about to assess the impacts. And kind of, we do it through several different survey methods or techniques. And our bread and butter one, at least for cave bats, are these hibernaculous surveys. So every other year, we go into a selected number of caves, and because they have a fidelity to the cave, they have a fidelity to the passage in the cave, we can go in there and we can count them, or you can take pictures and go back to your office and count them. And so we can look at population changes that way. Fall swarm surveys, we'll talk a little bit more about that, and then the summer surveys as well. So in Virginia, there are over 4,000 caves. We don't survey even 1/10 of them. Really, we've probably only surveyed in the neighborhood of maybe about 200 caves. And of those, there's probably only about 20 some that we've surveyed on a more regular basis. So that's what you're looking at here. We took a pre-white nose average of our counts at these caves. And here you can see typically we would have a little over 20,000 little browns, 3,000 tricoloreds, and close to 1,000 Indiana bats. So I just left this with the 2019 count in there. We did a count here in 2022. It really doesn't change these numbers much at all. We didn't do anything during the COVID years. But here you can see these declines. I mean, little browns, 99% decline, in our cave systems. Tricolors, 90s. The Indiana bat, that's one of the federally listed bats, and it was declining before white nose showed up. And so if we were to use the highest count that we had for Indiana bats as opposed to an average, that this percent decline would be closer to 80%. Fall swarm, again, what you can do, because these bats are coming back, they're flying around the entrance to the cave, they're going in and out, they're not really going in and hibernating yet, they're staying close to the cave, and they're basically roosting out in the trees and foraging. So you can go there and you can catch them, and you can look at, a catch per unit of effort. In this respect, our average captures per hour. And if you look at 2009, just with those three species, little brown, northern long-eared, and tricolored, we were catching about 15 bats per hour there. You jump to 2011, and we're down to 1.5 bats per hour. And don't ask me what a half a bat looks like either. But what shows up here is this northern long-eared bat. So that's one of the cave bats. I didn't have information for it, as far as cave surveys goes, and that's because of its behavior when it goes into hibernation. It's not like little browns or tricoloreds or Indianas where they're hanging on the wall or the ceiling and you can basically just sit there and count them. Northern long-eared bats, they crawl into crevices, they go under rocks, and basically they are extremely difficult to find in a cave. So those numbers are just kind of like all over the place and they don't make a lot of sense. But this does when you look at these capture rates and how they changed over years. So to kind of confirm what we saw with the fall swarm with northern long-eareds, before white-nose came around, we did a lot of summer surveys, mostly looking for endangered bats, but we ended up catching northern long-eared bat. That was probably the number one bat we would catch out on the landscape. Again, this is one of those catch per unit effort tables here, and you can see with pre-white-nose, that catch per unit effort was 1.36. Interesting that in 2011, it jumped by over 100%. But then it started going down in 2012, and then by 2013, when we were out there doing the work, you'd have to take a book with you because you just could not catch a bat on the landscape. Then just kind of some anecdotal information. We had been following some little brown maternity colonies, and most of these are kind of artificial roosts, if you will. They are in barns and bat houses. So there were 6 sites that we looked at. All of these sites had well over 1,000 bats in each one. If you go to look at 2013 and just look at the zeros, we lost 4 of those sites. And that Craig barn is up in Rockingham County. And that thing, it was our biggest one out there, 4,000 to 5,000 bats in there. When we went out there, we couldn't find a single bat that was left there. So what are we doing to really kind of address this issue? Well, the main approach at first was really one of kind of trying to slow the spread down. And of course, the only way we could slow the spread down is basically the human spread of it. So caving is big, and people love to get out there and cave. And so that was one means of potentially spreading it. So if you went caving in a cave that had the white nose syndrome, it's going to be easy for you to pick up the spores than if you decided to jump a couple states over and go caving, then you potentially had, could be spreading that. But cavers were great about it. We came up with decon protocol so that they could decontaminate all their gear if they were moving between sites. And then a lot of the cavers that are really kind of more hardcore, maybe they'll cave back here in the east, Virginia, West Virginia, Tennessee, and then they'll head out to Texas or someplace out west and cave. So they basically set up dedicated gear so that they didn't even worry about the decon with their gear back east. They had specific gear that they would take out west with them. So basically, people were just, trying to pull anything and, stretch the limits of how to look at this situation and what to do with it. So some folks came up with this artificial roost. And I didn't really follow it that closely because it sounded a little strange to me. But basically in the hibernacula, they were building these contraptions to basically put a warm spot in the cave, thinking that the bats would go there and utilize it. And basically it didn't work. So a lot of the approach that's been going on now for, 5+ years or so is really trying to look at some kind of a treatment, whether it's a fungicide or a vaccine. And the other thing that they're looking at, and it kind of falls in this same respect, is when I had talked about some of the species not really being impacted by the fungus, it's because what they found is that there are other fungi and bacteria on bat wings that are keeping the white nose syndrome spores from developing into a fungus. So they're looking at all these agents. The problem with this is, how do you take something like this and apply it on the landscape? So here you've got an animal that obviously it flies, it moves around a lot, that winter habitat, which is probably the best place to treat large quantities or large numbers of bats. They're in caves and mines, and some of these caves that we go into, they're 13 plus miles long. So, if you were looking at some type of a fungicide where maybe you could get rid of the fungus in the cave, I'm not certain how you go about treating, something that large. And then if you're going to treat the individual itself, they've come up with lots of ideas with, spray systems so that as bats fly in and out of the cave, they'll get a fungicide or some kind of a treatment sprayed on them. But that gets very problematic as well. All right, so that pretty much, wraps up, white nose syndrome and what we know about it. So we're going to switch over to the other topic, which is wind energy. And so when we were talking about the white nose syndrome, white nose fungus, that really was a cave bat issue. Now when we look at wind energy, we kind of flip, and this is more of a tree bat issue here. And what you're looking at, both of these are red bats. This is the only species that we have, at least here in the east, that is sexually dimorphic. You can tell males from females. This bat here is the male, really has that Irish setter red look to it. And this female here, they've got some, white tips on it. It gives them kind of this frosted look to it. So before I really get into it, I just wanted to throw some kind of pros and cons out there about wind energy, just for you to consider. But I think the biggest take-home point here is that, everything is a trade-off. So no matter what we do, there's give and take with that. So the pros to it, you reduce our dependency, basically on oil. In that process, you're going to offset greenhouse gases, and by doing that, you're going to reduce or offset the health issues that are associated with burning fossil fuels. There are wildlife benefits to it. Mainly probably one of the big ones is habitat loss, and mostly with mountaintop removal. I think another issue that probably should be in here is climate change. So we don't really know how climate change is going to affect some of these bat species, but there's that potential in there as well. And then, of course, it is a very low-cost energy source out there. Kind of the cons to it, I throw visual in there, but that's in the eye of the beholder. So depending on how you look at it, it's either pretty or it's ugly, I guess. Reliability is an issue because you can't predict wind. So you don't know when wind's going to be there. So if you are an energy supplier and you want to use wind energy, you can't really rely on being able to get X amount of wind energy, during the month of June or July, because you just don't know how the wind's going to flow out there. Logistics has more to do with getting the energy to the user. So basically, it's an infrastructure issue. So the winds basically, out in the Great Plains or off the coast, and we don't really have the best means of moving that energy, from where it's being generated to the end user. And because of the reliability issue, there's the argument that your contribution to the reduction or offset of the greenhouse gases is limited, because you can't, because you're not reliable with that energy source. And then there are wildlife issues with birds, bats, and habitat loss. So I'm obviously going to focus on bats, but there are bird issues out there, and with respect to the habitat issue, each turbine requires 3 to 5 acres of cleared space in order to put the turbine up and then to maintain it. But it's easily argued that this is a temporary loss of habitat. Once it's gone, the habitat can grow back, whereas mountaintop removal, once you remove that mountaintop, you're not going to get it back very easily. All right, so let's talk about bats and wind energy. So when wind was really first starting to get going here in the United States, it pretty much was out west. And when you heard about that, you heard mostly about bird issues out there and more raptor oriented. So eagles and other raptors were the ones that were getting hit by the wind turbine blades and obviously was causing some issues there. So what they started to do was to do these fatalities searches and trying to get a better handle on what they're actually losing. And when they did it out west, they really were not picking up a lot of bat fatalities. So when then moves to the Midwest and to the East, they continued to do these surveys, mostly with the idea that they were wanting to look at the impacts on the avian fauna out there. And what they found is that, yeah, there were some impacts to birds in the Midwest and the East, but all of a sudden they start finding a lot of bats out there on the ground. And so early on, you see the one reference to 2007. When they first started looking at this, they were looking at the number of bats killed per turbine per year. Turbines have changed a lot. That's kind of switched now they look at bats per megawatt per year, because most of the turbines they're just so many different sizes these days that a turbine doesn't really make as much sense as a megawatt does. So there were 2 papers out in 2013. They both looked at turbine fatalities in 2012. I think their data sets were a little bit different, and basically they are reliant upon wind facilities to provide them with that information. So Hayes estimated that just over 400,000 bats were killed just in 2012. Arnett and Bearwald estimated 200 to about 400,000. And then more recently, In the 2020 paper, they were basically looking at reported fatalities out there. And so there were reports anywhere from 600 to about 950,000 bats killed per year. And I think part of that is just you've got more wind energy development between 2013 and 2020. So obviously you're going to get more fatalities out there. So what does it look like? 22 species have been killed in the US and in Canada. And when you look at it, it really is the tree bats that are getting hit. And 72% seems to be the average out there for tree bats, and hoary bats making up a big chunk of that. But it does vary by site. So there are a few places where some tree bats got hit kind of hard by wind facilities, but I think that was siting issues. So they had a wind facility that was probably located close to a major hibernacula for little brown bats. And that's why they really had that high percentage of little brown bats showing up in their fatality searches. So why are bats, why are they coming to these turbines in the first place? And basically, there are a number of attraction theories for it. Because when you look at it, there's really not a good reason for them to want to come there. But most of these fatalities are occurring during the fall migration period. And again, that's also when the reproductive period occurs. So bats are getting together. The tree bats are not coming to a cave. Usually they're going to different roosts, and that's where they're all meeting up and reproduction is occurring at that point. And so one of the theories is that they look at these turbines on the landscape and up on top of ridges, and if you got 50, 100, 200 turbines up there, it looks like this mega roost out there. Another theory out there is insect attraction. So the nasal part where the motor is on the turbines, it generates a lot of heat and it draws in a lot of insects, and so there's a prey base for them to come to. So it's really hard to say which, if not maybe all of those, are reasons why they're coming to the turbines. But basically, there is an attraction there. And part of that is they will do pre-surveys before they build a wind farm. And so they'll go out there and they'll do these acoustic surveys or mist netting surveys to look at what bats are on the landscape. Well, there's no reflection between what's out there before they build it versus after they build it. All of a sudden, after they build it, they've got a lot more bats coming in. But there really is a ray of hope here, with tree bats and with wind energy facilities. And so when they've done these studies out there, and they're doing these fatality searches so they can relate the fatalities with basically climatic conditions out there. So they looked at some, kind of other things like, is it concentrated at one, end of the wind farm? Does it have anything to do with lighting? And basically, it's the bottom bullet that really stands out. So these bats are being killed at low wind speeds and basically when you have weather fronts moving through. So with that, basically they come out with at least a couple main approaches to trying to minimize impacts to bats. One of those is deterrence, and the other one is operational adjustments. So with deterrence, basically this is radar jamming. So bats are out there, they're flying around, and they are sending out echolocation pulses. They're bouncing off of objects, so they're getting distance and direction through that. The idea was that you basically clutter the airwaves. They just built these devices that would send out high frequency sounds, and they tested this, and it actually worked. So over ponds where they could put these devices out on one half of the pond, basically clutter the air with high frequency sounds, the bats really did avoid those sections of the pond, and they would go and forage on the other. So it looked very promising. But the problem is that high-frequency sounds attenuate over a short distance. And typically, bad echolocation calls travel about 20 to 30 yards. And so it works over a short distance, but when you look at these turbines, and especially more of the modern day turbines, they keep getting bigger and bigger. And so the challenge here is how do you get that signal out to cover a greater area around the turbine? And that's been a real limitation. So another alternative is to look at this cut-in speed. So these turbines, when they come from the manufacturer, they've got a set cut-in speed, typically at around 3.5 meters per second. If you raise that turbine speed up to around 6 meters per second, what you see is you get a great reduction in the fatality rate out there, anywhere from 50% to over 90%. And one study did show that at least as far as power production goes, it's not that limiting, at least from their perspective. So a 1 to 3% reduction in your power output, mainly because that wind's pretty low. But you also have to consider that the profit margin is not that great for wind facilities. Their efficiency is not that great because basically they can't produce energy unless the wind's blowing. So their efficiency is in that 30 to 40% range. Unlike, unfortunately, like a nuclear plant or, any other coal fire or something like that. I mean, they're 90+% efficient out there. And the other thing too is that it might be easy to sit here and think, well, so you lose 1 to 3% of basically your production. But when that money comes out of your pocket and with that low profit margin, it's not an easy pill to swallow. They have tried some other approaches to it as well. Ultraviolet light actually looked like it had promise to it. But I think what ended up happening with this, and I don't believe they're pursuing it so much today, is it just seemed like the bats just got used to it. And where at first it seemed to bother them and deter them, over time they just stopped paying attention to it. So what I kind of want to show you here at the end is more of a movement of where wind energy is going. So for the most part, it's been inland, up on top of the mountains, and now it's moving offshore. And mainly because you've got better winds, and I think the winds just blow longer out there than they do onshore. And so there's a federal agency, BOEM, Bureau of Ocean Energy Management, and they are the ones that basically kind of control the offshore leases for where the states can build wind energy. And so what I'm going to show you is that basically all the way down the states, from Maine here down to New Jersey, you see where they've blocked off areas for wind energy development. You come down Delaware, you may be familiar with Dominion Power is working on an offshore facility off Virginia Beach there. And then all the way down to Florida. And some of these states actually have a couple different lease areas to them. So kind of what brings in some concerns from a wildlife perspective and from a bat perspective is what impact is that development going to have on bat migration in the fall? So I'm showing you bird migration here, mainly because we have a good handle on how birds, move both in the fall and the spring. We really don't have a good handle on how bats move at all. I mean, we're trying to delve into that now, but you're probably all familiar with the Atlantic coast flyway for birds. If bats have the kind of the same thing there, then in this slide here, the red dots I kind of put in where those offshore leases are going to end up. Then if you're a tree bat that's up in the New England states or up in Canada, and you're heading south to the southern states to overwinter, you may be running a gauntlet of offshore wind facilities if that's the migration path that they end up taking. And so with that, that's just kind of overview of bats, a couple issues that are impacting them, and I'll be more than happy to answer any questions that you have. Thank you. Oh.
How many bats do you suppose there are now? Is there any census of the extant bat population in the East?
You mean with respect to both those issues, a white nose and wind energy?
Well, we've had a 97% reduction, but from what to what?
Okay, so well, I showed you what we had here in Virginia, at least for those handful of caves. I mean, we went from 21,000 down to, I don't remember exactly what that number was, but it was just hundreds. And there are places like there are bigger hibernacula up in like New York and Pennsylvania and Vermont. They had caves with over 100,000. They're down to less than 10,000 in there. And so it's hard. And with the tree bats, so with cave bats, it was easier for us to get a handle on them, again, because it's easier to count them. They come to the same place, every year, and you can go in there and see how those population changes. Tree bats are so much harder because they don't congregate together, and they're just out on the landscape. So we really don't have a very good handle on, what that core population is or was and what's left today. But you saw those figures when you are, killing 600 to 900,000 a year. You also remember the biology. They're only producing 1 or 2 young per year. So you knock a population or a species back by 90%. To be able to recover from that's not going to be very easy. You're not a mouse that's going out there and having 3 or 4 litters a year, and you're having, 8 or 10 pups in your litter. So it's going to be something that's going to take a long time. Well, I hope there's always hope, but I think probably so definitely with the tree bats, there are options out there. Certainly you can do curtailment. They can look at other means of lowering the impact on tree bats. That's just a difficult one, mainly because no one wants to pay for it, I guess is kind of the bottom line. With cave bats, unless they come up with some way of treating or dealing with that fungus, I think what you're going to see is a cyclical fashion with it. So basically, the fungus loses its prey base because basically it's killed it off for the most part. And so the spores in the fungus basically drop off and die down. And so now the bat population starts to grow back up. So when it gets to a point, all of a sudden, the fungus is going to kick back in and probably knock the population down. So I think until you really get a handle, on the fungus in some way. Also let me say this too. Bats are responding to it as well. And so something that we're seeing is that they're going into hibernation later and they're leaving hibernation sooner. And what they notice more up in New York and in the New England states is that bats are getting fatter before they go into hibernation. These guys are small. So little brown bats are typically, maybe 8 or 9 grams at most. And so now they're picking them up 10 grams plus. So basically, they're trying to make some adjustments as well to it. So that's a plus there. And we still follow some of these little brown colonies, the maternity colonies, and we're seeing reproduction occurring, and we're seeing survivorship. So we've got some bats now that are like 9 or 10 years old, which is good. So that means, they're still going back there and they're still getting infected with the fungus, no doubt about that. But it seems like there are some that are surviving it better than others. And it may be because they're putting on this extra weight going in. But. Sure, she's coming to you. Okay, so the question was, the fungus came from Asia. Well, it was actually Eurasia, so we don't know if it was from Europe or Asia. And so that goes back. That fungus, I think they traced it back to like probably the 1930s to 40s, somewhere in there. So I don't know that they really have an understanding of the impacts on those species over there. So they may have had very big populations, but they really didn't have the populations like we used to have at some of our sites. Again, some populations with hundreds of thousands out there. And so I think white nose still shows up out there, but those species have probably adapted to it to some degree over time.
Do bat boxes make any difference at all?
Yeah, so the question is do bat boxes make any difference? And so I'll just say yes to make it easy. But so when you put bat boxes up, basically, it's a habitat feature out there that is considered a limiting resource out there. So if you've knocked populations back by 90%, that roosting habitat is probably not an issue anymore. But they do have, but species do have fidelity to them. Little browns and big browns love bat boxes, and they love barns and old houses. So they will utilize them, and they have fidelity to them, and they will come back from year to year. So it's worth a shot.
I've noticed over the years that insect populations have declined dramatically. I can remember as a child turning on the porch light and having it swarming with moths and other insects, driving down the road and having my windshield smashed with all kinds of insects. Now you don't see that. Hardly any insects, it seems, are flying around. So I'm imagining that has a big impact on the bats as well. Your thoughts on that?
Yeah, so I don't know that anybody's really looked at that, as far as any real correlation between changes in, say, insect diversity and numbers out there and then bat population changes. But a number of these species had actually been doing very well before white nose came around. Little brown bats especially. I mean, their numbers were increasing, and it was considered probably the most common bat that we had out on the landscape, at least here in Virginia and perhaps back here in the east. So I don't think that prey availability was really an issue that was affecting them because their numbers were good and they were increasing. But it was white nose that really knocked them back. But I agree with you, there are issues, and probably more with some of the species that are perhaps a little more finicky about what they eat. So those bigger bats really are moth-oriented or moth-driven bats. So if you start really impacting moth populations out there, I could see that affecting those bigger bat species.
Does white nose mortality decrease on a north to south gradient due to length of winter being shorter I mean, you showed populations in the Gulf South where I assume insects are available much later
Right,
over a longer period of time.
Yeah, so I think probably yes and no. So I think in some areas, so I don't think it's been picked up in Florida yet, but it has been picked up in Texas. But I don't know that they're really seeing the impacts there. But you would think that would be the case. That, you know, number one, your hibernation period is going to be shorter, and probably your opportunities to get out and feed in the wintertime are greater than the further north that you go. But I know that they have, you know, they still have shown some pretty significant losses. The other thing that we're starting to see is that there are some populations that seem to be disjunct from cave or karst systems. And some of those are coastal. So they have these populations of specifically kind of like northern long-eared bats, maybe some little browns and Indiana bats that are coastal. And they don't seem to be as heavily impacted by the white-nosed fungus. You know, their roosts are going to be different than being in a cave situation. So that may be part of it as well. And then West Virginia, they have seen in more of like kind of the coal country that they've got some, I'll call them a little stronger populations for northern long-ears, but they're still declining, but probably, you know, at a less significant rate.
Can you talk a little bit more about white nose syndrome and recreational caving? Are the decon procedures still in place? Are there cave closures and so on?
Yeah, so with respect to recreational caving, it's, gosh, I hate to call it a moot point. Maybe something that it did, you know, bring out there is, you know, what else have we moved between caves, you know, that probably isn't having an impact on anything, but perhaps if you knew diversity of, you know, say different, you know, fungi or whatever that's in a cave, you know, a lot of that is potentially moved by humans. I don't really see it as a big issue with white nose syndrome now. With respect to cave closures, I think it just depends on the group. I don't know so when it first came around, Forest Service, at least in the southeast region, closed their caves, you know, to recreational caving. So I would have to look into that. I don't know if they've opened those caves back up or not. So you know, right now, decon certainly is not going to hurt anything, you know, moving between caves, and certainly could keep the movement, you know, of other things between caves as well, even if they're not as detrimental as, say, white nose.
For bats here in the valley, is there something we can do in terms of habitat if we have some land to help them? So someone mentioned bat boxes. Are there species of trees that help the bats around here? Is there anything that we can be doing to help, or are they sort of on their own course, given the forest and caves around here?
Yeah, I think that, again, it's kind of one of those situations where when you lose 90% of your population out there, a lot of things that were perhaps limiting factors before, whether it's habitat or roost, you know, almost become moot because you just don't have the individuals on the landscape anymore. I wouldn't let that stop me from doing, you know, habitat management for them. I mean, certainly, you know, they like dead and dying trees, snags. They like trees that have sloughing bark, so the shagbark hickories, sugar maples, you know, anything like that. And I don't know if you know what a wolf tree is, but basically they're just old trees that were left out in farm fields, and they're just old, big, scraggly trees. They like stuff like that. And, and just the barns too. So, unfortunately, showing you the little brown maternity colonies, I mean, we lost 4 of the 6 there, and, that's just not a habitat issue at all. But. Well, there was a question down here. I don't know if you still want to ask or not, but she had a hand up initially.
I was just kind of curious. We have 3 bats that come out every evening at dusk, and just how to tell where they are staying. How do we know if they're tree or cave, or is there a way to tell?
Yeah, well, I probably should have clarified this beforehand. I kind of forgot about it. But so again, when we call them either a cave bat or a tree bat, that really has to do with where they're hibernating. In the summertime, basically everybody's a tree bat. There's only a couple species that use caves year-round. So gray bats, and gray bats are all the way down in southwest Virginia, basically the Tennessee Valley drainage and just over into the New River drainage. They probably switch caves between summer and winter, but and then Virginia big-eared bats, and they're basically Highland, Bath County area, very limited up there, and they use caves year-round. But all the rest of them, so this time of year, you're going to see everybody out on the landscape because everybody's moving, and it's hard to tell when they're on the wing. If you've looked at them enough, you can probably tell like a red bat from other bats, and you might be able to tell a tricolor just because of size, but you're going to have to look at a lot of bats to, pick that out. But.
Thank you.
All right. Thank you.
Thank you so much for coming. Don't forget to sign up